In the past, building out the infrastructure for an application required teams to architect a solution that could support growth up to a certain point. For example, it was a pretty common practice to design a static architecture that was a bit over-provisioned in the hopes that it would support the user load for 2 to 3 years without requiring any major architectural changes. And the problem with this approach is that it's extremely difficult to determine how much resources you'll need over a long period of time. And on top of that, if you over-provision the number of servers and storage to allow for growth over time, you end up spending a lot of money on unused capacity. So a better approach in the modern era of cloud computing is to take advantage of a platform that can scale out on demand when the application load increases and then scale back down when the load drops. So this concept is known as scaling horizontally. And for example, let's say that we have an elastic load balancer that distributes application traffic across a couple of web servers. We can place these servers in an auto-scaling group, and if the demand for the application suddenly increases, the auto-scaling group can launch additional instances that can handle the load. And the idea here is that the performance of the application isn't negatively impacted since we're able to scale out dynamically. And when the load for the application goes back down, we can automatically terminate some of those extra resources that are no longer required. And again, the performance of the application stays the same since fewer users are accessing the system. Now, there's a few things that you should keep in mind about building horizontally scaling systems like this. And the main takeaway here is that you should consider building stateless applications to make this as easy as possible. For example, a stateless web application stores no user session information locally, and users can bounce from one web server to another without any issues, and the servers don't need to have any knowledge of who they are or what they were doing if they were previously connected to another server. When there's no session state that needs to be shared between servers, new ones can be spun up on demand as needed and then torn down when the load decreases, and the individual servers supporting the application don't need to be aware of any of their peers within the system. And in contrast, stateful applications may store data locally on disk or in memory on the server, and the server needs to understand what the user was doing previously if they were connected to another server in the application. Now, it's not uncommon for a web application to store session state for a user to understand how they're interacting with the system. And in a stateless application, this can still be achieved by storing session state in a backend database like an Amazon RDS database or a DynamoDB table. And this allows those stateless nodes to retrieve the information from the database without having to be aware of what the other servers in the system were doing. So stateless application architectures are better candidates for horizontal scaling because it's much easier for servers to come and go without any issues. And it's not impossible to achieve horizontal scaling with the stateful application, but it will require more work and it will probably add complexity to the architecture. You may be able to mitigate session state issues with stateful applications and horizontal scaling by implementing something called session affinity. And what this means is that once a user is connected to a server, they stay connected to that server until their session is complete. But the main limitation with this is that when the architecture scales, existing users won't be able to make use of new compute nodes that are launched to support the application. So these are just a few of the things to think about when implementing elasticity and horizontal scale. And we'll see some concrete examples of this when we get into the next module. For now, let's take a look at scaling vertically, or scaling up instead of scaling out. So when it comes to scaling vertically, you're basically just increasing the capacity of an existing resource. So this could be adding storage to an existing instance, or it could be upgrading the server to a more robust instance type that has more CPU, memory, and networking resources. So let's take a look at how we can scale vertically with a single EC2 instance. This is actually pretty simple to do, and you may have run across this while studying for your associate level exam, but all you need to do is go into the EC2 console, and from there, find the instance that needs to be scaled up, and then you'll need to shut the instance down. So right-click on the instance, go to Instance State, and then click on Stop. Once the instance is powered off, you can right-click on the instance, and then go into Instance Settings, and click on Change to change the instance type. And that'll actually bring up this screen where you can pick a new instance type from the drop-down list. And here you can see that the one that was created was a T2.micro, and that's a pretty weak instance type. And from there, we could just pick a larger instance type from the drop-down list like an M4.large, and then click on Apply. Once that's done, simply power on the instance and you're ready to go. Now there are a couple things to keep in mind here. First, you can only change the instance type like this for EBS-backed root volumes. So the operating system disk must be an EBS volume, and you can't use this process for servers with instance store-backed root volumes. And this typically isn't a big deal because most AMIs these days are built to run on EBS. The other thing to remember is that you need to select a new instance type that's compatible with the original instance's virtualization type. So the majority of AMIs these days are built for the HVM or the hardware virtual machine virtualization type, but there are some that use paravirtual or PV virtualization. And you just need to maintain this compatibility when moving up. And the nice thing here is that the drop-down list is only going to show you the compatible instance types, so this is usually pretty obvious. But as a best practice and for the best performance, you should use a current generation instance type when deploying new servers. So for example, if you're using general purpose instances, use the M4 series versus the M1 series, and then you can use HVM-based AMIs. And this will give you the most flexibility when it comes to scaling up and changing to a larger instance type in the future if you need to, and it'll also give you the best overall performance. So now that we have a good grasp on scalability, let's move on to the next video and we'll take a look at implementing disposable resources.